My name is Daniel. Everyone calls me Raniz, except my parents. I'm a consultant at a company called Factor 10. And as a consultant, I see a lot of people's pipelines. Or I'd rather say I get exposed to them. Because a lot of them isn't really up to snuff. And I think all of us in here, if we're developers, we interact with our pipelines daily. They're probably gating us before we can get our code into our main repository. So I'm going to talk a bit about pipeline patterns and anti-patterns, what I've seen when I've seen my own pipelines, mistakes I've made, mistakes I've seen others made, and hopefully what to do instead. So we're going to try to reduce 3 things here. And the first is frustrations. How many people in here have had a pipeline failure that was fixed by just pressing retry? Yeah? Does that make you feel good? I hate when that happens. So we're going to try and avoid that. We're also going to try and reduce boredom, which is the wait times. Pipelines, I think if you follow continuous integration, the aim should be a 10-minute build. If you have a build that's longer than 10 minutes, you should try and make effort to reduce the build time. How many people in here have a build that's longer than 10 minutes? Huh? Longer than an hour? Longer than 5 hours? Yeah, there's at least someone in here. If you have a build pipeline that runs for more than 5 hours, you get 1 chance a day to get your code in. And if it doesn't work, you have to retry, and then you have to check back the next day. And that really makes us less productive. And the third thing we're going to do, we're going to try and save the environment if we can. Sometimes we might need to spend a few more compute cycles to speed up the pipeline. But if we can, we're going to try and reduce both the compute time we spend and the real time we spend waiting on our pipelines. And before I get into all the patterns and anti-patterns, there's an elephant in the room that I need to address. And that is that there is probably around 5 to 10 different pipeline platforms that you all use in this room. Most of what I say is applicable to all of them. And in the few cases that I show examples, they're going to be in GitHub Actions, YAML. I think there's only like 2 or 3 examples. But everything I say is applicable to whatever platform you're using, most likely. Jenkins, Azure DevOps, GitHub, GitLab, CircleCI, Travis, Dagger, Earthly. This works on all of them. And the terms I use is usually just pipelines, jobs, and steps. We also have stages. The terms differ between the platforms, but hopefully you can follow along. So let's get started. Anti-pattern number 1, the ritual. And this is where we do everything all the time, every time, which means our pipeline follows a ritual. This usually happens quite organically when we start out. We might have a PR pipeline that does the linting, testing for front-end and back-end, runs the test for front-end and back-end, and then runs the integration tests to see if everything works. But then someday, you get a bad merge. The PR pipeline didn't catch everything. There was a merge. It wasn't a merge conflict. We can have bad merges that aren't merge conflicts. We can have changes in different files that are incompatible, so the build fails after we merge. So to make sure that we catch that as soon as possible, now we also run the same pipeline after merge to main. But then one day, something externally changes. One of our dependencies change, or one of the external systems we talk to make an update, and something in that API changes. So our code breaks, but we did not catch this before it came into production. So maybe we decide, well, let's just run everything nightly as well to make sure that all the tests still pass, even if the code hasn't changed, because the outside world can change, right? And then we figure out that, well, someone needs to run this. Maybe our product manager they want to run this application. They just want to be able to grab an artifact, install that to the computer, and run it. So we add on a publishing step at the end. Now we have 3 pipelines that run on pull requests, on merge to main, and on nightly. That does all the linting, all the tests, and publishing artifacts. Every PR, every merge to main, every night. And The PR artifact is probably not used. The main artifact is definitely used. And the nightly artifact is just waste, because that's the same artifact that we built on main, but we just rebuild it every night. So what we should do instead is we should have the right pipeline for the job. That is, one specialized pipeline for PRs, one for merge to main, and one for nightly. So when we merge to main, we probably don't need to run the linting tests, because it's very improbable that those will fail when they pass in the PR. The same thing with the nightly. We don't need to run the lint, we don't need to run the unit tests, because that code hasn't changed since we last run them on main. The only thing that can change during every nightly run is the outside world. The code in the repository is still the same, so we don't need to verify that. And this means we'll waste a lot of less resources by just running the steps that we need. And the way we can do this is we could specify these as separate pipelines, one for the PR, one for merge, and one for nightly. But we can also use conditional pipeline steps, which is pattern number 2. So here we have the PR pipeline again. Depending on what has changed, we may not need to run all these steps. If, for example, we only change something in the front end, we don't really need to run the backend tests and the backend lint. And if we only change something in the backend, we don't really need to run the front-end tests and the front-end lint. We still need to run the integration tests, because those are affected by both the backend and the front-end. But if we, for example, just change the settings menu, I'll just run the front-end part of the pipeline. And if we only change something in the database, just run the backend parts. And this saves us a lot of time. So how do we accomplish this? Well, here comes one GitHub example. This is how you do it in GitHub. This solution is similar for all other platforms. What we do is we have a pre-step, which is this. In this case, I'm using a custom actions called path filter. And this just checks which files have changed in this branch from the main branch. And it sets flags. So we define that if something has changed in the backend directory, we should set the backend flag. And if something has changed in the front-end directory, we should set the front-end flag. And then we export these out of this job, and we can use them in another job. So in this case, we say that this job depends on the paths filter, and we use the outputs. So we see the backend lint now only runs if the pre-step determined that the backend has changed. So if no files have changed in the backend folder, this step is ignored. And we can do this not just with files, but with branches. We can see if it's built on the main branch, we do this. If it's a nightly trigger, we don't do all the unit tests and linting, for example. Really powerful, can make you skip a lot of unnecessary tests or steps. Antipattern number 2, hoarding, which is where you produce these artifacts all the time and you keep them forever. This is not only a problem if you're running something on premises where you need to worry about your storage. No one wants their builds to fail because you ran out of disk to store your artifact. That's not a fun solution, it's not a fun problem to have. So clean up regularly. But it's also a problem even if you're using some cloud service. If we disregard the environmental cost of storing artifacts or your internal builds from 10 years ago, which you're probably never going to use. I don't think I've ever actually retrieved an artifact that's older than a month. But it's also a problem of finding them. So this is a GitHub repository for an open source project. They have slightly more than 7,000 Docker images published on their registry. And if you want to find a specific in here, there's no search. You need to go through more than 64 pages of images to try and locate the one you're looking for. That's tedious. And most of these have been downloaded. You can see all of them has been downloaded 211 times. And if all 7,000 images have been downloaded 211 times, that's probably something automated and they're not used anymore, so you can delete them. Antipattern number 3, the aesthete, which is where you order your steps naturally instead of practically. this is something that's easy to do because we have this idea of, well, this should be in this order because it feels right. For example, this is usually how you structure your pipelines. I still do this quite often. We have a setup, we do a lint, because that's cheap, right? Linting is really fast. We might do a format check. Then we compile everything. We run our unit tests, because those are at the base of the testing pyramid. Then we run the integration tests, because that's the second layer of the testing pyramid. And then we get to the top of the testing pyramid, which is the end-to-end tests. But depending on the project, and in my experience in the projects I've worked with, the step that usually fails the most, that's the integration tests. Personally, this is because I do test-driven development, so I run all the unit tests while I'm developing. So I typically don't check in failing unit tests. I might forget to run all the integration tests, though, because I usually develop with integration tests. So those are the ones that fail. Now, in this pipeline, we spend 2.5 minutes linting, then 5 minutes compiling, another minute running unit tests, and then we get to integration tests, which means we get a failure after 13 minutes, almost 14 minutes. But if we take into account that the integration tests are usually the ones to fail most often, we can put them as early as possible. So we reorder our pipeline. So now we have the setup and the compile at the front, because we need to do those. We can't run the tests before we compile. And then we run the integration tests. And now we saved 4 minutes before we get the red signal telling us that we've messed up. Which, I mean, this is almost a 10-minute build. Until failure. We still need to rate the full pipeline for the green check mark, but we get the feedback of the failure earlier. Antipattern number 4, the one pipeline. One pipeline to rule them all. One pipeline to bind them. This is where you have just one pipeline. It does everything in sequence. This is an example pipeline for a Rust project. It has a front end and a back end. The front end is written in TypeScript, I think. But we do back end setup, linting, compilation, tests, and then we do the same for front end, and then we finish it all off with the integration tests. If we run all of this, it takes 24 minutes and 40 seconds, which is a long time. This will definitely mean that we start a pipeline, we go do something else, we get back to the pipeline and see whether it failed or not. But the back end and the front end is independent, right? They have no code connection. We can compile them and run the tests separately. So if we just split this up into separate pipelines, which is pattern number 4, parallel pipelines, we can divide this into 3 pipelines. We have one that does the back end, one that does the front end, and one that does the integration tests. Now, we get the feedback after almost 15 minutes instead. But as we can see, we need to do the backend setup and the backend compile in both the backend pipeline and the integration test pipeline, and the same for the front end. We need to set up and compile the front end in both those pipelines. So we do double work, which is bad for the environment. So the total runtime here is about 8 minutes longer than before, but we get the feedback much earlier. But there are tricks that we can use to reduce this duplication of steps. We can use artifacts. So if we run the backend pipeline and the frontend pipeline, and then we run the integration tests on the results of those. So we publish an artifact after all the tests have passed. Then we can run the integration tests on the backend and the frontend artifacts, which are already compiled. We don't need to set up, we don't need to compile. We just use the already compiled result. Slightly longer pipeline, 16 minutes, but the runtime is just the publishing steps longer than the original pipeline. So we're losing about 15 to 20 seconds, but we're saving ourselves 8 minutes of wait time. But we can actually do this a bit better because there's really no need to run the tests before we publish the artifact. If we publish the artifacts as soon as possible, we can run the integration tests at the same time as we run the backend and frontend tests and lint. So we just restructure into 5 pipelines, which depend on each other. So now we do the minimum possible to get the artifact. That means setup, compile, publish. And then we use the published artifact for the backend linting and tests. and the integration tests, and the front-end linting and front-end tests. Here we get the feedback from 12 minutes, and the runtime is essentially the same as the original single sequence pipeline, but we've saved about half time before we get our green check mark, which is a huge gain. Anti-pattern number 5, which is gift wrapping. I might be in the wrong branch here. We'll see if we can get through all of them. So this is where you use wrapper tasks instead of command line tools. Now, Azure DevOps is a huge fan of this. Microsoft produces all kinds of wrapper tasks for all build systems out there. They don't want you to run the .NET command. They want you to use the .NET task, which does a lot of hidden magic, which might ruin your workflow. That happened to me. We replaced the .NET task with actually calling the .NET binary, and everything just magically started working again. So this is what you shouldn't do. For example, for a cargo project, when I wrote this, there wasn't an action for cargo. Now Microsoft has decided they need one as well, so there is one. Don't use it. Just run the actual cargo command instead. I mean, even if you use the YAML formatting, multi-line syntax, which, by the way, has its own website because it's so complex, you can structure it so it's actually more readable than the wrapper action YAML. You should still use tasks that set up your tools for you. So use the setup Python tools to install the correct version of Python. Use the setup poetry tasks to install poetry. Use the setup Rust task, but don't use tasks that call the tools for you. Call them explicitly. Anti-pattern number 6, which is complicated pipelines. And this is where the pipeline is its own software project. I've seen this, the most egregious case was a Jenkins pipeline that consisted of 4,000 to 5,000 lines of code that solved all the pipelines in the entire company. This is what their repository pipelines look like. If you want to change this, you need to change the source code for the Jenkins library, compile that into a jar file, upload that to Jenkins, update the version number in this file, and then you can run it and see if whatever you changed worked. Terrible, terrible use case. And I was tasked with porting this to GitHub Actions. So that's 4,000 or 5,000 lines of Groovy code that should be ported to GitHub Actions YAML. That was not a fun project. What I think you should do instead is you should have composable pipeline libraries. Build actions that you can reuse. Here's examples for a Rust application where you break out the compile steps, the testing steps, and the publishing steps. And you can use this. You can even bring this into a composed pipeline where you can reuse the entire pipeline. But now, when you have this, if you want to go back and maybe change one of the steps, you can just replace it with this. You're still reusing the steps, but you can insert something in between or tweak something, or maybe you have certain things that needs to be compiled before the application. You can compile them, then call the composable action. So don't build a single pipeline that solves every problem. If you do that, make sure you split it up into reusable parts. Just apply architecture. It's software architecture. Reuse, dry, whatever principles you really like. This also brings me into anti-pattern 6.5, which is when you're entangled into your platform. And this happens when you have 4,000 or 5,000 lines of Groovy code in your pipeline. It's really hard to change platforms. So try to make as little use as possible of the actual pipeline platform you're using. There are tools that are much more general. For example, I tend to use Make. I have a Python project template that uses Make. So the entire Python pipeline for that just consists of making sure we have the right Python version, installing the build tool, and then we just make CI. And the make file contains all the checks, it runs all the tests. And the really good thing about this is that with this make file, we can actually run the pipeline locally. So when I develop, I just execute make CI before I commit. And then I can see, well, the pipeline is very likely to pass because all the tests pass, all the linting pass, all the formatting passes. Antipattern number 7, Groundhog Day, which is where we start over from scratch all the time. This is more common nowadays, where we have ephemeral builders. Back when we were using Jenkins, you checked out on top of the old build, and you just continued from there. This is error-prone, so nowadays we just start over, which means we have a blank virtual machine, probably, which downloads your code, installs all the build tools, builds your code, and then just disappears. We can do things to alleviate this. For example, here is a Rust pipeline again. We set up, we fetch dependencies, we run the linter, we compile, and we run tests. Takes around 12 minutes. The first step, the first pattern for solving this is caching, pattern number 7. And typically when we talk about caching, people go, well, let's cache dependencies, because that's easy, right? We cache our node dependencies, we cache our cargo dependencies, and it will speed up the build. We change the fetch dependency step into a cache restore. Then we fetch dependencies if the cache misses something. Maybe we have changed something, so we need to refetch. And then we update the cache if something has changed. Now, this is a good idea for several reasons, but it doesn't really save you any time. In the Rust case, this is 80 or so dependencies downloaded from crates.io. Restoring the cache takes 4 seconds. Checking that all the dependencies is there and updating cache takes around 1 second in total. Compare that to downloading everything from scratch from crates.io, which takes 7 seconds. So we save us around 2 seconds, which is not really worth it. There are other benefits, which means not relying as much on the internet, but it doesn't save us that much time. What we can do instead is caching the build output. So we just do the same. We add a cache, restore, and update before and after we lint, compile, and test. That means that we can use the incremental build just as if you were developing locally. This doesn't work for all languages. It typically doesn't work for TypeScript, JavaScript, transpiling, but it works for C, C++, C#, Java, Rust, a whole host of other languages, Go also probably. I haven't tried it. And this saves us a lot of time. So in the Rust case, linting goes from 2.5 minutes to slightly less than half a minute. Compiling is reduced by almost more than 3 minutes. And of course, the testing step, you still should run all your tests, so that's not affected. But we save almost 7 minutes by just storing a few 100 megabytes of data in the cache. We can also cache container images. This requires build X if you're using Docker. This is also the same as when you run locally. If you run the same Docker build again, it will only run the steps that's changed. Typically it doesn't work on builders because they throw away all the images that were built in between. But we can point this to another registry, another image in the registry. You need to use separate images. You can't use the same image as you're building because the cache is different. But we just pointed to reading the cache from and to that image, and we can save a lot of time. In this case, we run cargo install for a tool. That tool typically takes 6 minutes to install, but since Docker could find the image cached, it's now only 8 seconds, so that saves us another 6 minutes. Down here, something has changed, so we need to run this step from the beginning, which takes, in this case, also 6 minutes. But instead of 12 minutes, we only do it in 6. I am running out of time, so let's talk quickly about tooling images, and then I think I'm done. So tooling images is where we build an image containing all of these tools that we need, instead of installing them when our pipeline starts, we build a Docker image, and then we run the rest of the steps with that image. We can use conditional pipeline steps with this to make sure that we only build the image when it's actually changed. So in the top case here, we build the tooling image, we publish this as latest, and then when a PR comes along, we check, has anything changed in the build image? No. Well, then we skip building it, and we reuse the latest image that we built on main, saving us all the time spent installing tools. And if we change something, we rebuild the image, and we reuse that image for the rest of the build. And here it's really important that we don't use a shared tag. If we store this at latest, we might run into a situation where another build comes along, overwrites our image, and then our later steps is run on the new image from another branch, which might be incompatible, causing build failures, where we need to hit retry. And that's me out of time. So I'm Raniz. Thanks for listening to me. The QR code there is not malware. If you want to connect with me on any social media platforms, you'll find me there. And we might have time for some questions.